a plane is flying overhead with a constant elevation of 4,000 feet. So I think this constant elevation of 4,000 feet is going to be important. A man is viewing the plane from a position 3,000 feet from the base of a radio tower. So for sure, I need to draw a picture. So let me draw a picture here. This is going to represent the ground. Okay. Let's draw a little man over here. That's the man. This is the tower. And then I'm going to put a dotted line representing the flight of the plane. So that's not dotted. Hold on. This represents the flight of the plane. What else do they tell me? They tell me that the plane is 3,000 feet away from, the man is 3,000 feet away from the tower. So from here to here is 3,000. I don't need that dotted. Hold on. From here to here, it's 3,000 feet. What else do they tell me? They tell me that the height of the plane where it's flying, that's a constant 4,000 feet. I guess you didn't know that the plane was going from left to right yet, but if we read the next line, it says, the plane is flying horizontally away from the man. So I draw a horizontal line and I make sure it's going away. So what I could do is I could put a little dot representing the plane. Mainly I do this because I can't draw the plane can't draw the plane so well. So it's like the plane is here, then the plane is here, then the plane is here, and the plane is here. The plane is moving. This red dot moving across. Does everybody understand the situation so far? We've read 3 of the sentences and I'm trying to construct a story that makes sense. Any questions? Okay. If the plane is flying at a rate of 600 feet per second, at this point, I think I need to introduce some variables. So what I'm going to do is, well, let me keep reading the question first. At what rate is the distance between the man and the plane increasing when the plane passes over the radio tower? So I think this is what's happening. Okay. Here's one line. Here's another line. Here's another line. Another line like that. So this picture that I'm drawing right here, these, you should see, like, here's one triangle, here's a second triangle, here's a third triangle. I'm really trying to mimic this drawing that I drew of a balloon inflating to understand the situation. And what I really need to do is I really need to introduce some variables. Okay. So one variable that I need to work with, well, I guess my first comment is that our basic situation is we're going to be working with triangles. So let me just draw one abstract triangle to represent our situation over here. Okay, so this is one of the triangles that we have over here. And in this case, the plane is right there, right at this dot. That's where the plane is. And the man is at the bottom right here. That's where the man is. And I want to label the constants and I want to label the variables. So this side right here, is that a constant or a variable? What do you think? Constant would be correct. And that constant is 4,000 feet. Is this side right here a constant or a variable? That guy would be a variable. Why? Because the plane is flying. So for me, I like to label the variables. I like to label horizontal variables as X. I like to label vertical variables as Y. And I like to label diagonal stuff as Z. So that guy is, oh my God, that guy is X. The Y part is not a variable, it's a constant. And distance from the man to the plane, I'm going to call that Z. Does everybody understand this scenario? So as X increases, the plane is flying away from the man. At that same time, that distance between the man and the plane is increasing. Okay. So now I want to look at this line that says, if the plane is flying at a rate of 600 feet per second, this 600 feet per second is a rate. It's a rate of change. In fact, it's a velocity, right? So I want to write d something dt is equal to 600 feet per second. And my question is, do I put an x here or do I put a z here? What are your thoughts? Well, this is how fast the plane is flying. The movement of the plane is represented with the x. So this should be a dx dt. Okay. Now, what is this question actually asking for? This question is actually asking for at what rate is the distance between the man and the plane increasing? Right? So they're really asking me for dz dt. That's what the question is. Okay. But they want to at a particular moment. So the particular moment they want it at is when the plane passes over the radio tower. So the question is, how do I know when that is? And the answer to that question is, maybe I'm not going to have a particular time. Maybe it's a particular value of x or z. So how do I know when the, or maybe I should ask this, what should the value of x be when the plane, when the plane is flying directly over the tower? Does anyone know what that x value should be? Because I claim they give that to you. It is 3,000. So I put the 3,000 down here, but the 3,000 could also be here. Does that make sense? So the man is here. I put a vertical up like this. If it's 3,000 down below, then it's 3,000 up above here. So we can put a 3,000 over here. Okay. 3,000 is correct. 3,000 is correct. Any questions so far? Is this going too slow? Like trying to unpack it very clearly in the hopes that you can unpack it as well. I can do it faster if you wish. Just give me a signal. Well, I shouldn't go fast now because now we got to create our model. So there are various right triangle models that we can use. But in this particular case, we want to relate the three sides of a right triangle. Does anybody know what relationship exists between three sides of a right triangle? This is a very famous theorem. I'm going to relate the variables. This is where creating the model comes into play. And these variables are related using something called the Pythagorean theorem. So how does the Pythagorean theorem work? The longest side, which in this case would be z squared, is equal to the sum of the squares of the smaller side. So it would be x squared plus 4,000 squared. Does that make sense to everybody? Any questions? No? Okay. So at this point, what we want to be able to do is we want to relate the rates. So when we relate the rates, we can differentiate both sides with respect to time. With respect to time. Okay. So let's see if you could do that. If I take the derivative of I differentiate both sides, this side, and I differentiate this side with respect to time. So what's the derivative of this left-hand side over here? Can anybody tell me? You can unmute yourself. What's the derivative of this left-hand side? Someone in the chat box type 2z. Do you guys agree with that answer? Or does someone want to augment this answer? We're missing something. What should go over here? It's dz dt. See, here's where, I never taught you to write z prime, right? Because does z prime mean dz dx? Does z prime mean dz dt? It's like it's unclear. Z prime is not descriptive enough. That's why we always write it with Leibniz notation, so it's clear what I'm differentiating with respect to. Okay. So if I came back over here, maybe instead of chain rule, I should have written implicit differentiation. I mean, it's the same thing. But that's really what we're doing over here. So we take the derivative of both sides with respect to time. So having seen that guy, what's the derivative of x squared? That would be 2x times dx dt. That's right. And what's a derivative of 4,000? Just so that we're all on the same page here. Simple line. 0. Okay. Great. So I think we're in pretty good shape here. Reminder, we're looking for dz dt when x is equal to 3,000. So why don't we solve for what dz dt is? So I'm gonna take my dz dt and divide both sides by 2z. I get 2x over 2z times dx dt. And that's just equal to x over z times dx dt. Right. Now I wanted to evaluate this when dz dt, when the x value is equal to 3,000. So I go to substitute in, I'm going to get a 3,000 up here. I have a z down below here. My dx dt was given to be 600, so I could put 600 over here. But we still have a variable here of z. So the question is, what's z equal to? Does anybody know how I can find z? If I know that x is 3,000? Any thoughts on how I can find the z? That's right, Pythagorean theorem, right? So I know that my triangle kind of looks like this. It's ugly. My triangle kind of looks like this, like this. This is 3,000. This is 4,000. This side should be the square root of 3,000 squared plus 4,000 squared. Is that 5,000? I'm guessing it's 5,000. It's 5,000. Does that make sense? So really this becomes 3,000 over 5,000 times 600. Okay. And that's going to give us 360. Final question. What are the units? What are the units going to be? Well, we were measuring everything in terms of feet, and the velocity of the plane is in terms of seconds. So I think this should be 360 feet per second. Let me check that. That doesn't, let me check with my calculator. Hold on one sec. 3,000 times 600 divided by 5,000. 360. Okay. Cool. All right, great. Let's take a look at another example. Actually, let me recap first. What did we do? We tried to draw a picture to understand the situation. Within that picture, I tried to show something is changing. Then I took a snapshot at a particular instant in time. And the reason why I did this is I wanted a simple picture where I could label the variables and label the constants. Once I add that, I want to unpack the information they gave me and figure out what I'm looking for. After I got all that information, I need to use this diagram to relate the variables. Once we have our variables, we related the rates by using implicit differentiation, aka the chain rule. I solved for the quantity that I was looking for. I had to do a little bit of side math to find a missing side in order to plug in all the numbers to get my answer. Okay.